Hello and welcome to Chaos and Caffeine. This is my pre-international trip presentation, I guess, or whatever you want to call it. In any case, if you're following this on YouTube, please like and subscribe. We're trying to build a little bit of a following. I'm always looking for ideas of what you want me to cover, especially technical, energy, stuff like that. In any case, this week we are going to have a little fun with something called Wake the Hell Up Coffee. And as you can see in the picture and what I have here, this I had ordered through Amazon. I was able to get a couple of surviving pods. Let me get one. Most of them look like this, though, unfortunately. But it brings up an interesting point. I said, I like a lot of caffeine, and technically the studies basically say you're not supposed to really have more than 400 milligrams in a day, and I probably do that in my first, sip of coffee. In any case, so Wake the Hell Up Coffee, that is from... So, by the way, I recommend you go to wakethehellup.com if this turns out to be a good coffee, and order it direct, because I'm sure they will package it better than putting it in a paper bag or plastic bag and shipping it with no padding or no structure. So that came crushed. So I got two good pods out of it. One's in my cup and one's in the other cup, assuming that this works out. Then we're going to quickly discuss what's going on. There's quite a bit, but I'm going to talk a little bit about what I'll be working with CIGRE. At the same time, unfortunately, as the CIGRE USNC representative, I was supposed to be in Montreal this week, but we had a job that went horribly wrong. So I was instead, and am instead, going to Dubrovnik for the European meeting in Croatia. In any case, we'll talk a little bit about what we'll be doing there. That's going to be the main subject. I don't want to spend too long today. Let's see what this looks like and why, before I drink it. I haven't had my coffee yet today. Why this is very interesting. So this one has 450 milligrams of caffeine per 8-ounce cup. I'm going to read off some per 12-ounce cup real quick. So the top one, according to caffeineinformer.com, if you want to check it out, Black Label brewed coffee at 12 ounces is 1,555 milligrams. I think we're going to have to find that one. Very strong coffee, 1,350. Taft coffee, 1122. High voltage coffee, and their branding looks almost exactly the same as Death Wish. So I have to see if that's actually Death Wish. That's 1150 per 12 ounces. Black Insomnia, 1105. Cannonball Coffee, Maximum Charge, which is out of the UK, 1101. The high voltage coffee is Australia. Death Wish Coffee, which is New York, 728 milligrams per 12 ounces. So that one we've already covered. I'll tell you what, with the amount I drink, it didn't even make a dent. Then we get into like 48 fluid ounces, which is like 640, but that's 13 milligrams per fluid ounce. That's not that high. They slipped it in there because that's per container or per measure. Then we get down into 500 and less. So this one definitely falls in that 500 and less. But there's another one somewhere. I don't know if it's the same company yet. I've got to look it up, called Wake the F Up. And that one I thought I was originally ordering, and I got Wake the Hell Up. So let's give it a shot. This is also a very dark coffee. I didn't make it particularly strong. I did a 10-ounce brew. So let's see how it tastes. Actually, kind of a hint of chocolate. So, might be smooth. I get that little bit of a bite, but not as smooth as last week. Last week's coffee, which was pretty good. Let's yep, Relia Squatch approved, but not as good as last week, but really good. So I'll be able to drink this today. When I get back in a couple of weeks, I'm going to do a longer session. We're going to cover that Simpson 260. Next week, I'm going to cover some of the stuff going on in the other meetings. So my road trip is going to be 5,017 miles. So in any case, let's get into some fun. Get all this stuff here. So I don't have any delays or shutdowns of the computer. Okay, so the whole thing, what CIGRE is, it's a consortium of basically utilities, countries, etc. There's 100 and some countries involved, and it covers very large machines, grid, etc. So my responsibility is study groups for what's called A1, which is power generation. So your generators, very large electric motors, things like that. So that's my responsibility. One of the things I'm working on is what's called A1.78, which is supposed to be kind of the definitive guide for applications in electrical and current signature analysis. So we've put together a team. It's relatively small. I have a couple of the companies that are involved in electrical and current signature analysis, spectral analysis for this one involved. For the work I'm doing, because I was asked to take on IEEE 1415, that kicks off in January because we're allowing the existing PAR to disappear, and then the new PAR has already been set up. It launches in January. So in the meantime, I'm putting together that team. And actually, we may do some pre-work. We'll see what November and December looks like work-wise. If it's light, then we'll be working on that. And then, of course, one of the meetings I'm going to have in Croatia is with the publisher I'm working with on the second edition of Practical Electrical and Current Signature Analysis of Electric Machinery and Systems. Now, in all of this, what we've done is we're blowing away the bullshit that's been out there about the limitations on current signature analysis that we've run into. I put in some papers to certain organizations that have made alternative statements to that, usually by companies such as companies that solely do vibration analysis and so on, that are basically fighting back because of their investors. So we'll just leave it at that. So that's kind of my thing on that. So instead of playing that game this year, I will actually effective after the Mobius conference. I was going to go to SMRP, like I said, so do not count SMRP in my statement, but I will be doing fewer of the commercial conferences next year outside of speaking engagements, because my goal is to focus on the engineering and consensus side of the technology. I've already got electrical and current signature analysis in the Gearbox playbook for American Clean Power. That's for wind turbines, et cetera, et cetera, et cetera. Now, my presentation at CIGRE, because I've been asked to focus on the clean energy or alternative energy or whatever you want to call it, basically wind turbines, battery, and solar, is called the practical application of electrical and current signature analysis in doubly fed induction generator turbine systems, which is quite a mouthful. And for those of you who are wondering what that means, is when you're driving down the highway and see the big spinny things out there in the field, most of those are this type of turbine. I'm going to be talking about the reliability aspects of that and what we've been doing, in particular MotorDoc, as well as other organizations, because this has been all collaborative in looking at reliability issues with those towers in order to control costs even more. Now, contrary to what is heard in certain stations and certain news programs, which are primarily editorial, alternative energy processes, which I've always called it that, except, politics and stuff like that, is actually one of the least costs per megawatt hour in the industry, which is why when the costs hit certain points, they don't want to operate the large turbines. They'd rather operate clean energy because it's a lower cost operation because of fuel and even the maintenance costs and everything else per megawatt hour. Otherwise, they wouldn't do it. We're in a deregulated state and everything else. Nothing I've heard in the last, couple of years has made much sense on that standpoint. But, when you talk to people and you put out something for whatever reason, including things like the invisible birds, which is a previous episode, etc. So here's the story. One of the reasons why this type of technology is important has to do with the fact that we're pushing for more and more data centers. 2% of energy used in the United States, electrical energy, it goes into water and wastewater. So the stuff we're using every day, right? Let's put this into perspective. Right now, we are more than 8%, closing on 10% of the electric power generated in the United States is going to data centers. That's for AI, that's for your phones, that's for your computer, cloud storage, all that stuff, right? Not including cryptocurrency, which is another 2.5% to 3%. Okay, let's put this into perspective. So more than 10% of all the energy being produced right now, closer to 12%, is going to feed these things. That is one of the reasons why you are watching your electrical prices go up, because the grid has to be able to manage it. It is basically, there's only so much energy available. All this flopping back and forth on policy, both in each of the administrations, not pointing at any one, but each of the administrations going severely one way, then severely the other way. It's like, I liken it to going into an automotive plant and say, oh, we're building cars today. Well, tomorrow we're going to build teddy bears. So it's not something you just do overnight. The other problem is the ability to get all the permits necessary to build any type of power plant, let alone build them, takes, on average, 7 years to start, and that's the simple ones, which are wind and solar, and can take up as much as 20 years, say, for instance, for a nuclear power plant. That means that a portion of that has to do with how long local groups are allowed to litigate and fight with lawyers to make money. Because that's what it's all about, folks. It's all about money, right? So, it's like how close to extinction are the invisible birds I keep hearing about? And I'm looking at a picture of a site that we videoed and drove through, which I'll link that episode. So, in any case, part of what we're there for, and part of the discussion I've been having, and I will be involved in a debate because I also sit on the IEEE Grid Code Committee, has to do with what happened in the Iberian Peninsula, and that's Spain. And I talked about this as well in a previous episode, and that was the fact that if they had used the solar and wind that they had in place properly, chances are they could have ridden through most of it. The part of the problem still with that had to do with settings. There was a whole list of issues there, but But one of the biggest ones that allowed the voltage to rise was they did not use their alternative energy for voltage control. Now, why is that important here? And I mentioned the term data centers, right? So if we're coming along and we have one of the new mega data centers, now it's going to be small, 500 megawatt, okay? To put this into perspective, that's a lot of freaking power, okay? So a coal-fired power plant, we visited one very large coal-fired power plant. It had two 500 megawatt generators that were meant to service almost all of Oregon. Well, one of those two is dedicated solely to a data center. So if you have that much energy disappear in an area, well, all of a sudden, what's holding back the voltage? So as you use more energy, as you have more demand, your voltage comes down, so you generate and you increase that voltage using certain techniques. So if I come along and I'm stretching that rubber band back and I'm giving it a little bit more so I can keep that voltage up, all of a sudden I release some of that energy, my voltage rises suddenly. Okay, so a 500 megawatt plant goes down instantaneously, boom, it shoots up. Well, that happens in maybe a second if you're lucky. The only thing that can react fast enough is an electronic counter system, and that's one of the things they're using wind, solar, and energy storage for, is all of the new modern controls allow you, since about 2012 or 13, allow you to do voltage control in addition to some frequency control. The only thing they can't really do right now is something called black start. Now, what black start means is you've lost all power, you have no power at all. Well, you need a little bit of power to generate power. So on a big generator or something, they'll start it turning and they'll have batteries to supply power. In the case of wind turbines and so on, they can kind of do it using the UPS, which is primarily there for their controls. But really they need something like grid forming technology, which is something we're investigating. And that's important. One of the reasons I'm doing the paper I'm doing has to do with the fact that certain conditions in the field do damage to wind turbines. The other things they talk about that we've been hearing about has to do with grid inertia. Now, all of a sudden, these people who've never heard of the grid are talking about grid inertia as if they understand what they're talking about. And that's basically if something happens, like you lose something, that you can ride through it. No. It has to do with if I have sudden changes in the frequency, because if I'm here in the US, it's 60 hertz. If I'm over in certain areas in Europe or the rest of the world, it's 50 hertz. If I float outside of that by a little bit, well, it causes all kinds of problems from everything. Well, your electronics, your clocks, your lighting, all kinds of stuff go haywire and can be severely damaged, right? So they have to control frequency. So that's another aspect of this, is you need to control that frequency so you don't get any kind of resonance, meaning just like a mechanical resonance, you get an electrical resonance. So the larger machines were built to absorb a lot of that grid inertia. The older wind and other technologies were not. Now they're doing some level of grid inertia electronic control. However, some of the practices they put in place to protect that cause a resonance, like a fast vibration that just starts to accelerate out of control between basically in the electrical system. So we end up seeing it in the turbines themselves, and it causes damage to the rotors, which can cause them to fail. So that's actually the number one cause of failure for the generators. There's a whole lot of other things we're looking into in order to make improvements as well, including something called circulating currents. For those on the technical end, it's the same thing that causes bearing fluting in a standard machine when you have variable frequency drives. Well, same thing occurs up tower, and there's a lot of reasons for it. we'll talk about that in a longer training session in a few weeks, in end of October or November. In any case, that's what I'll be talking on there, and then we will have another meeting at Grid of the Future, which is all of the U.S. utilities and government organizations and IEEE and others meeting in Colorado in early November to discuss similar things. I'll be speaking there as well, similar topic, more educating people on what wind, solar, and energy storage is capable of doing, and that's about it. Now, don't get me wrong, that's not the only thing I'm involved in. I do work with, we were just out troubleshooting a pipeline, things like that. So, so I'm as involved in traditional energy systems as I am in some of the newer stuff. I just personally, I just saw a lot of fun troubleshooting some of the larger scale issues that turned out to be, I thought they were U.S. No, it's global. We've got partners in Brazil and Mexico and Canada, throughout Europe, Japan, et cetera, et cetera, et cetera, all working on similar issues, including Australia. So everybody's kind of seeing it. We had developed the only method to detect it without having to climb, or in cases where you do have to climb, gathering data with like 5 pounds worth of equipment versus all the other stuff, and doing it well, from the base you don't have to de-energize system, but that's neither here nor there. That's my little bit. By the way, speaking of commercials, I'm wearing my RDI hat today. RDI is motion amplification. We are a user of RDI technology. I've used it a couple of times recently. We're looking at some projects when I get back from this trip, in which we are looking at some large-scale, long-term issues. So that is that bit of fun. Final announcement is that we have kicked off the MotorDoc Very Large AI project. That is the project name. We may look for some additional support in the development to that project. It will be a U.S.-based project. We do at MotorDoc and MotorDoc AI. We do not use subcontracted programmers outside of the country, we'll say. We discovered recently that we are probably the only ones doing that at this point in our space, but that's neither here nor there, with a couple of exceptions. We've talked to those exceptions and are working on some partnerships. But in any case, we may be looking for some support. I have some plans for 2026 with this. It has to do with filling in a bit of a technical gap using AI, and using some very specific expertise, information, and work that's come on in my over 41 years in the business. So guarantee that we will not find anybody else doing a similar project when this is all done. And no, we were not going to give details on it, but it will make a lot of sense when it comes out, and it will provide a lot of support for people in the industry, especially if you're starting out. So we've got some business decisions to make on it as well. The project is well underway. We're doing a lot of classification work right now, and we will talk more on that later. I'll give you some updates on what's going on, but let's just say, we'll call it AI. I'll have thinking when it's doing what it's supposed to be doing, but in reality, it'll be a machine learning project, and how we host it, I haven't decided yet. I am not a fan of putting stuff on the cloud, so we will determine how we approach that. But it is kind of a culmination of 41 years in the industry. I plan on having it out by the 42nd year, with the ability for it to continue expanding indefinitely. So with that, have a great time. I am looking forward to my 12 hours of flying time, or 14 hours of flying time, including stops tomorrow, followed immediately after we land by an 8-hour drive. So in any case, I will see you next week, and my next podcast will be coming from Dubrovnik, Croatia. So basically, if you watch the HBO series Game of Thrones, I will be at what do they call it? The main palace, the capital of the Game of Thrones thing. So in any case, we'll get some pictures. Have a good one. Be safe, and we'll see you next week.